Hello, my name is Brendan Prosky, and I'm doing the doubler rivet pattern optimization project. So for a little background, I'm a structural design engineer on the F-15. What I do sometimes is work on what's called a retrofit, where we take old systems out of an existing aircraft and put new ones in. So here I have a picture of a pump system on an existing aircraft, and when we go to replace this pump with a new one, sometimes it'll take different electrical wires or ducts that are coming out of it or into it to make it work properly. So there aren't always holes for where these new systems need to run through. So I've identified a spot there in the yellow box that shows where there's an open space to run a new electrical wire or duct through. So going on to the next slide, what we do to make the structure as strong as it was originally when we put this big hole in it, we've slapped what we call a doubler on there. And so this doubler basically is the same thickness as the existing structure, and you put it on top of it to double the thickness of the structure. But to attach it properly, you have to use rivets and put them in a pretty even pattern on this doubler to properly connect it and make it act as if it's one piece of structure. So here I have manually optimized the rivet pattern myself. It took about an hour or two, so that's kind of why I would really like to make an automated system in which it perfectly places these points and fits the most points you can at the best positions very easily. So my solving method for programming this and making it happen is first to create the surface of the doubler within MATLAB, then to set up a grid on the surface of the doubler of possible points for each of the fasteners. And the grid size that I chose was 0.001 by 0.001 inches in size. And then next I wanted to create random points on the grid that meet the input constraints. So to properly position these fasteners, you need to have them at 0.32 inches or 2 diameters of the fastener from the edge of the part, the doubler, and also 0.65 inches apart. So that'd be 4 diameters of the fastener between each fasteners. So next I was going to run the program and see how it turned out. So the input, here's a couple lines of code from my program, and you can see what you have to put in there. First is the number of fasteners, which is, in this case, I counted from the previous picture, 16 is what I determined to be the manually found optimal points. And then next you put in the diameter of the fasteners, which is 5 32nd fasteners, and then you create a polygon using all the x and y coordinates of each of the corners of the doubler. Also, if you put a higher number than what number of fasteners that can actually fit on the surface of the doubler, the program will spit out an error, but it will actually put in the maximum number of fasteners that fit. So next, I ran my program, and you can see the surface of that same doubler, with the orange line and the black line for the circle in the middle. And then you have all these points that popped in there with blue circles around them. So each of those circles is a distance circle, which is at 4 diameters that has to be in between each point. So as you can see, no point falls within the distance circle of any other point. Next, I have a picture here of a close to optimized looking pattern with all the distance circles turned off. So you can see all these points fell in there, and they're all a nice distance apart from each other and meeting the constraints that I put in. So what you can also see, though, is the limitations of my program currently. First of all, it only creates random points, and so each time you run it, a different thing comes out. Also, the program can only stay proper distance from the edge of the doubler, but not from the features inside the outline, such as that hole that I put in the middle of the doubler. So the next step would be to add a genetic algorithm aspect to keep working until the fasteners are evenly spaced, and also figure out how to keep the fasteners from the edge of any features within the doubler itself. Thank you.